Hello Year 10. Today we are going to be sketching parabolas by completing the square. So sometimes we are lucky enough to have an equation already given to us in turning point form, which would be in this form here, y is equal to a bracket x minus h squared plus k. And then we can just read off the turning point, which is h and k. However, most of the time, we have expanded equations, and if we want to know what the turning point is, we will need to complete the square. So this is what we are practicing today. So let's look at our examples. Example number 1 says to plot the graphs of the following equations. On each graph, make sure that you state the axis of symmetry, the coordinates of the turning point, and the y-intercept. So our first parabola is already in the correct form, so I don't need to factorize anything. So because it's already factorized, I can read off the turning point. So from the bracket, I have x minus 3, so the x coordinate will be a positive 3, and the 18 on the end is the y coordinate of our turning point. We also need to work out whether this is a maximum or a minimum. So the minus 2 in front of the bracket, the minus more specifically, means that this parabola is concave down. So that's not an accurate diagram. I haven't worked out any of the intercepts, but that's what concave down looks like. So that means if there's a turning point at the top here, that is going to be the maximum value that that parabola gets to. So this one, because of that minus sign, this is going to be a maximum. Part B, find the y-intercept. A y-intercept is always when x is equal to 0. So if I put that into my equation, I get y equals minus 2 bracket 0 minus 3 squared plus 18. If you put that into your calculator, you get 0. So the y-intercept is 0, going through the origin. Find any x-intercepts if there are any. The x-intercepts are when y is equal to 0. If I put that into my equation, I will get 0 equals minus 2 bracket x minus 3 squared plus 18. Sorry, there should be a 2 in there. So I'm going to move that negative 2 with the bracket. I'm going to move all of that over to the other side so that it becomes positive. Then I can divide the 2 away to get 9. Then the next thing to do is get rid of the squared, so I'm going to square root. X minus 3 would be equal to plus or minus 3 when I square root the 9. And then moving the negative 3, moving that across the other side, it would become a positive 3. So I have plus or minus 3 plus another 3. So that means my two solutions are going to be positive 3 plus 3, which is 6, or negative 3 plus 3, which is 0. So that one's not really a surprise because we kind of found that when we were looking for our y-intercept. Okay, so next question. Now that we've practiced finding intercepts, let's do a much bigger question where we have to sketch the graph by completing the square, and that means we're also going to have to find the turning point, the x and the y-intercept. And it does say they're in exact form. Okay, so to complete the square, we're going to start with y equals x squared plus 6x, the first two terms. Then we are going to halve the 6 and square it, which makes 9. So I'm going to add 9, I'm going to straight away take away the 9 again, and the plus 20 is sitting on the end. The first three terms make my perfect square. So factorizing, I will get x plus 3 in brackets squared. Negative 9 plus 20 is a positive 11. Okay, so now it is in the turning point form for a parabola. That means that I can read off the turning point. From the bracket, I get x equals negative 3, and then the 11 from the end is the y value of my turning point. Okay, next I would like to find my intercepts. So the y-intercept, which is when x is equal to 0, but it would be easy just to read that number from this original equation, because if x is equal to 0, the only thing that's left is that constant at the end, which means that my y-intercept is 20. My x-intercepts are going to be when y is equal to 0. I'm going to use my factorized version for this. So I'm going to have 0 equals x plus 3 in brackets squared plus 11. Then I'm going to move the 11 over to the other side, which makes negative 11. Then I would like to square root, but if I'm square rooting a negative number, that's not possible. So this equation here has no solution, which means that there are no x-intercepts. This is a parabola that is completely above the x-axis and will never touch it. I'll draw you a sketch. So this is what it looks like. We have a turning point at negative 311. That can be about there. Negative 311. And it's a concave up parabola. So it's going like this. And we know that that y-intercept here is at 20. So you can see that parabola is just going to keep going up. That 11 is the smallest y value it's ever going to get to, which is why that parabola is never going to get down to touch that x-axis. Okay, let's do another one. Part B. We'll start the same way. We're going to take the first two terms, x squared minus 5x. We're going to halve the 5, which would be 5 over 2, and then we square that to be 25 over 4. So we're adding on 25 over 4, then I straight away have to subtract it off again, and I also have a negative 1 sitting on the end. The first three terms are the perfect square. And when I factorize it, I halve that minus 5, which will be negative 5 over 2 squared to factorize that up. Then minus 25 over 4 minus 1 becomes minus 29 over 4. Okay, it's in turning point form, so I can read off the turning point, which is going to be a positive 5 over 2, or you could change that to be a mixed numeral, which would be 2.5. And then the y value is negative 29 over 4, which again, as a mixed numeral, is negative 7.25. My y-intercept is when x is equal to 0, which would be the negative 1 from my original equation. My x-intercept is when y is equal to 0, which I'm going to put into my factorized equation. So that would be 0 equals x minus 5 over 2 squared minus 29 over 4. Then I'm going to move the 29 over 4 over to the other side. And then I can square root that because it's a positive number this time. So x minus 5 over 2. The square root of 29 has to be in third form, but the square root of 4 is 2. So I can square at the bottom, but I can't square at the top. So I do have to keep it in exact form. And I also need a plus or minus on that. One more thing to do is to move that 5 over 2 over to the other side, which would be plus or minus square root of 29 over 2 plus 5 over 2. Those two fractions have a common denominator, so it would be easier to write that as 5 plus or minus square root of 29. All right, so let's put this on a graph. Ooh. We have x-intercepts at 5 minus square root of 29 over 2. Now, even though we have to keep that in exact form, if you wanted to, you could put that into your calculator, just so you know approximately where to put that. But our diagrams are not to scale, so it doesn't really matter if it's not perfect. But it is approximately negative 0.2, so it's quite close to the y-axis there. And then the 5 plus square root of 29 over 2 is about 5.2, so it's much further over here. So I'm going to label those. This is 5 plus square root 29 over 2, has to be in the exact form, not the decimal form. And this one will be the 5 minus square root 29 over 2. The turning point was 2.5, negative 7.25, which can be approximately there. And my parabola is going to go up like that, making my y-intercept -1. So make sure everything is labelled and in exact form. Okay, on to question 3. Sketch the graph by completing the square. So this is a little bit harder because there's a negative in front of that x squared. So we have to do our little technique of factorising that minus out, which will leave x squared minus 6x plus 4. Then, leaving the minus out the front, I take the first two terms, halve the minus 6, which is minus 3, and square that would be 9. So I'm adding 9, taking away the 9, and putting the plus 4 on the end. Factorising the first three terms, I would get minus x minus 3 in brackets squared. Negative 9 plus 4 makes negative 5. Once I've done the completing the square part, I'm going to get rid of the square brackets by expanding the minus out the front back in. So it's negative x minus 3 squared and plus 5. Okay, so there's my equation in turning point form. My turning point will be at positive 3, positive 5. Then my y-intercept, looking at the original equation, will be the negative 4. And the x-intercept is when y equals 0. If I put that into this equation, I would get 0 equals minus x minus 3 squared plus 5. Move the bracket to the other side to make it positive. Square root plus or minus root 5, and then add the 3 over. So it'll be positive 3 plus or minus root 5. All right, what is this going to look like? Now, we have to keep it exact on our diagram, but 3 plus root 5 is approximately 5.2. So that is 3 plus root 5, and 3 minus root 5 is about 0.8. So that one there is 3 minus root 5. The turning point was at 3, 5. So in the middle of that, 3, 5 will be about there. And the parabola is coming down like that, down like that. And then through the y-axis, that y-intercept there is negative 4. Okay, so we should have known that that parabola was going to be concave down because of the minus that was out the front when I did all that factorising. Right, one more, part B. We have a 4 in front of our equation here. So I'm going to start by factorising the 4 out, which will give x squared minus 2x plus 5. Then I'm going to leave the 4 and I'm going to make my perfect square. So I take the first two terms, take the minus 2, halve it and square it, which means I want to add 1, straight away take away the 1 again, and have my plus 5 sitting on the end. Factorising the first three terms of that, the perfect square part, will become x minus 1 in brackets squared. Minus 1 plus 5 is 4. Okay, then I want to times the 4 that is out the front. I'm going to expand that back out so that it's 4 bracket x minus 1 squared plus 16. Then it is in turning point form. So my turning point is positive 1 comma 16. My y-intercept from the original equation is the 20. So y-intercept is 20. And the x-intercept is when the y equals 0. So into this equation here, I would get 0 equals 4x minus 1 squared plus 16. If I move the 16 over, I get negative 16. I can divide the 4, but it's still a negative number there. So when it comes to square rooting that, I can't square root it, which means that there is no solution, no x-intercepts, because this parabola is not going to touch the x-axis. We have got a turning point at 116. So 1 comma 16, there's my turning point. My parabola is going to be concave up because it was a positive in front of my x squared. And my y-intercept we worked out was 20. And that's all we have. We're done. Time for you to practice in exercise 7D.